Hello everybody, welcome back to Algebra, and today we're going to talk about expressions with denominators. Now these expressions are going to look a little bit different because they're going to have denominators in them, and that's going to make them look a little bit trickier. However, they're just the same sort of thing, except we have to make sure that we have the matching denominator now, like in this problem. As you can see, we've got x plus 3 over 5, and we're adding it to x minus 5 over 5. And since we have the same denominator, we can add them and get this as the answer. Now, why do we get 2x minus 2? Well, that's because when we have the denominator there, once you have the same denominator, it's just adding. You've got x plus x, that's 2x, and we've got 3 plus minus 5, which is minus 2. Now in this problem, it's the same thing. We have the similar denominator, 5n, so we can subtract these two expressions on top, right? 6x minus 2 minus 3x minus 3, just like a regular problem. You could even write it like this without the denominator now, because the denominators are gone. We have 6x minus 2 minus the 3x minus 3, which is in parentheses because it was part of a different expression. So now what we could do is we could just distribute and solve. We'd get negative 3x plus 3. So 6x minus 3x would be 3x. And minus 2 plus 3, that'd be 1. So our answer would be 3x plus 1, but we have to put our denominator back in, because that's still part of the problem. So that would be our answer for that one. Now, just like in other problems with fractions, you're sometimes going to have denominators that don't match up, like in here. Our denominators are different. We can fix this by finding a common denominator. When you have variables in it, oftentimes the common denominator in these situations are going to be just the two denominators multiplied by each other. In this case, the common denominator would be x times x minus 3, because I multiplied both the denominators times each other. Now this might be weird to think about, but to make sure we have even denominators, we have to multiply to get that common denominator. And we haven't really thought about it probably this way in a while, but how we do that is by multiplying each fraction by 1, just a special kind of 1. Over here, I'm multiplying 1/2 by 3 over 3, so I end up with 6ths as my denominator. And over here, I'm multiplying 1/3 by 2 over 2, which is 1, so that I get 6ths in the denominator. I'm going to do the same thing for this problem. I'm going to be multiplying this side by x minus 3 over x minus 3, which is 1, but that's going to make my denominator have my common denominator in it. And the same thing over here. I'm going to multiply this by x over x, which is 1, so I have the common denominator of x times x minus 3. So when I finish multiplying the denominators together, you'll see that I have the same denominator now, because I've multiplied x times x minus 3 and x times x minus 3. That's going to get you the same thing no matter what. And because that part doesn't really matter that much, you don't even have to combine it. You don't have to simplify x times x minus 3 for this fraction to be added. It can stay as x times x minus 3. Less work for you. Now I did the multiplication on the top. X minus 3 times x plus 2, and x times x squared. Now I realize I haven't shown you some of that stuff yet. So I did the math for you down here, and this is what I got. Now all that's left is simplifying it. So there we have it. I've simplified it by writing that in reverse polynomial, or in polynomial descending order, x third plus x squared minus x minus 6 all over our denominator. Don't worry, there will be a video showing you how to do polynomials after this. I kind of got mixed up in my ordering. Oops, it's been a while. So don't worry, I'll make sure to have a link in this video that can send you to that if you get lost. I figured we'd do one more example though before we left. So here's my last example. We have 2x minus 3 over x plus 3 minus y over y. First things first is finding that common denominator. The common denominator in this case is going to be xy. It's just the two denominators multiplied by each other. So now, just like in the last problem, we have to multiply each side by 1, but a 1 that'll make our denominators the same. On this side, that means we'd have to multiply by y over y. Doing that will make our denominator xy, and we're still only multiplying by 1. And over here, we'll have to do the same thing, except multiply by x over x. That way we'll have our matching denominators. So there's our problem now. We just have two distributions to do to finish the problem off. Oh, sorry, I'm sitting down. Okay. So on the left side here, we have to distribute y into 2x minus 3. So y times 2x is going to be 2xy, and y times negative 3 is negative 3y. Then we've got x times 3, and we've got x times negative y. So there we have it. Those are our finished parts. Okay. So now we can simplify those. By adding our like terms, we've got 3x minus 3y. Those don't have like terms, but our 2xy and our minus xy are like terms, and that just makes xy. And that's all going to go over our common denominator, which, if you remember, was xy. And there we've done it. We've added two advanced expressions with denominators. I hope you found this video informative. And remember, I will have links to talk about polynomials for that first problem I did over here to make sure we're all good to go. See you guys next time. Bye.